Hello everyone and welcome to the week 10 part of examples from MyMathLab homework. Use L'Hopital's rule. To find the limit, check your answer using algebra. Okay, so first of all, this one would be 11 minus 11, so that's 0 on top. 11 squared minus 121 is also 0 on the bottom, so I can use L'Hopital's rule, which is good because that's what the directions say to do. So it's still going to say the limit as x approaches 11, and then the derivative on the top is just a 1, and the derivative on the bottom is a 2x, and then you can let the x become an 11, and so this is 1 over 22. And then for extra fun, I'm going to use algebra. So on the top, there's not much algebra I can do. On the bottom, this is the difference of squares, so this can be factored as x minus 11 times x plus 11. And then x minus 11 will cancel x minus 11, leaving a 1 on top. And then x is becoming an 11, so you can substitute that in. So it's going to say 11 plus 11, and that equals 1 over 22. So same answer, even though we do it in completely different ways. One of the wonderful things about math. All right, that was question number 2 on the homework. And then also, for some reason, I chose number 3. Oh, I know why I chose number 3. Okay. So same idea, if you plug in x, you're going to get 0 divided by 0, so we can use L'Hopital's rule. And then it's going to be the limit as x approaches 9. And on the top, the derivative is going to be 2x minus 1. And on the bottom, the derivative is just a 1. And now if I plug in the 9, there is no division by 0, so there's going to be 2 times 9 minus 1. And this is going to be 18 minus 1, which is 17. So that's L'Hopital's rule. Then, for extra fun, use algebra. Well, if they're telling me to do algebra, I know that the bottom can't really be simplified. The top most likely could be factored. And if this x minus 9 is going to get canceled, there must be an x minus 9 on the top. And then basically, I know that x times x will be x squared. Now I need to get a 72. And 9 times 8 is 72. And then I have it factored. So these are going to cancel. And then the x is becoming a 9, so if I put a 9 right here, that's going to be 9 plus 8. And once again, I do it in 2 completely different ways, but I get the same answer. And then I skip to number 10. Explain why L'Hopital's rule does not apply. So you can't use L'Hopital's rule for everything. It has to be that it's 0 divided by 0, or it's infinity divided by infinity. If it's any other form, you can't use L'Hopital's rule. It'll give you the wrong answer. So with this one, if you plug in a 4, this is going to be 4 minus 4, so it's a 0 on the bottom. But on the top, it's going to be 4 plus 4 is 8. And that is not this form, and that's not this form. That's why it does not apply. So let's see. This has infinity in it, and there's no infinity in here. There's no infinity. Although the limit of the numerator, the top, equals 0. No, the top does not equal 0. So this one says, although the limit of the denominator, so this says the bottom equals 0. Yes, I agree. The limit of the top is not equal to 0. Yes, I agree. So that is D. Okay, so hopefully you watched the lecture where I went through examples like this and I did all of the parts, finding the domain and the x-intercepts, the minimums, the maximums, where it's increasing and decreasing. Well, when you do it on the homework, it basically asks it part by part. So it will just ask you one part, and then once you do that part, then it asks you the next question, and then asks you the next question. So let me get a separate piece of paper and break down some of this. So this is actually number 17 from the homework. And the function is 5x times e to the negative 0.4x. And the first question asks for the domain. So for domain, you have to watch out for division by 0. This has no division. Also, no square root of a negative. This does not have square root. So the domain is all real numbers. So that's multiple choice. The domain is all real numbers. Then the next question, the x-intercepts. So for x-intercepts, that means you put the function equal to 0. So set it equal to 0. And the good news is this one is already factored. So then you could just set each factor equal to 0. And then this one, I just need to divide by 5 and find out that I get the answer 0 divided by 5, so that's 0. And the e function never equals 0, so this one has no solution. So the only answer I get is x equals 0. So for the x-intercept, the x-intercepts is or are at x equals 0. All right, what's next? The y-intercept. So for the y-intercept, that means you put x equals 0. So x-intercept means y equals 0. Y-intercept means x equals 0. So the function, if I plug in 0, is going to be, so just plug in a 0 and plug in a 0. So 5 times 0, and then e to the negative 0.4 times 0. Well, this means e to the 0, which is a 1, and then a 1 times 0 times 5, that equals 0. So I got the answer 0. So I got the answer y equals 0. So the y-intercepts are at y equals 0. So that's letter A. Okay, on to the next part. For any horizontal asymptotes, so the horizontal asymptote means you use L'Hopital's rule. And L'Hopital's rule is for functions that are fractions. And at first, it looks like this one is not a fraction. But a negative exponent, if you get rid of a negative exponent, that means you have to invert this part. So another way to write this function is that it's 5x over e to the it becomes positive, 0.4x. And then if you take the limit as x goes to infinity, then this will become infinity over infinity. So you can use L'Hopital's rule. And that will be the limit as x approaches infinity. On the top, the derivative is 5. On the bottom, the derivative of the e function is the e function. And then because of the chain rule, I need to take the derivative of this, which is a 0.4, and multiply. And since x is going to infinity, that means the bottom is going to infinity. So this one is going to 5 over infinity, which a 5 divided by a huge number is so small, it becomes 0. So that means I get the answer, y equals 0 is the horizontal asymptote. And then for my answer, the function has one horizontal asymptote. Type an equation. All right, y equals 0. If it happened to have two horizontal asymptotes, then you would type the 2 into those two boxes. Next up, vertical asymptotes. So a vertical asymptote comes from when the function is undefined because of division by 0. So that means for a vertical asymptote, you would put the bottom equal to 0. But then that means the e function equals 0, and that never happens. The e function never equals 0. So for vertical asymptote, there's none. And where is that? So here's the vertical asymptote, and there are no vertical asymptotes. And then where's the function increasing and decreasing? All right. Looks like I need a new paper. So I'm going to go back to how the function was at the beginning. And then where is it increasing and decreasing means I need to take the derivative. So this is going to be the product rule. Take the derivative of 5x is just 5, and then leave the e function alone. Product rule has plus, and then leave the 5x alone and take the derivative of the e function, which is the e function, then the chain rule, so times a 0.4. And then set the derivative equal to 0. And the next thing I'm going to do is factor. So I can factor a 5 out of each of these. I can also factor out an e. So I'm going to factor out 5 and the e function. And then what remains? When you factor all of this out, it leaves a 1 behind. And then plus, I factored out this and this, but I did not factor out the x or this negative 0.4. So what remains is a negative 0.4x. And now that I have it factored, set each factor equal to 0. So this one is going to be the e function equals 0, which does not have a solution. That's not going to help. And then set this one equal to 0. So 1 minus a 0.4x equals 0. And then I could add 0.4x to both sides, making it a positive 0.4x on the right side. And then divide by 0.4 and divide by 0.4. So x equals, how much is 1? 1 divided by a 0.4. So x equals a 2.5. And now it's time to look at the original graph and see what's going on. Okay, so here's the original function. It's got a 5x times an e to the negative 0.4x. And I just got x equals 2.5 as an important point. So what's happening at x equals 2.5? So it looks like at 2.5, that's a maximum value. So trace and plug in a 2.5. Yep, that's a maximum. So that means 2.5 comma 4.598 is a maximum value. And then the left side is increasing. So increasing from negative infinity until you get to the 2.5. And then from the 2.5 on, it's going to be going down. So then that's decreasing from 2.5 to infinity. And then let me just see what else was being asked. So the function is increasing on and never decreasing, so that's not true. The function is increasing and then decreasing, so it's B. So the function is increasing. So the function is increasing on negative infinity to 2.5 and decreasing on the interval 2.5 to infinity. And there's a local maximum at, and the part B got cut off, but it says there's a local maximum at x equals 2.5. All right. So there are some of them that ask all of these parts, but I think it's only about 3 or 4 of all the problems that ask for all of these parts. And then something that goes much faster. Find the absolute maximum. So that's where you have to graph it and look on this interval and see where out of the whole graph is there the maximum or the biggest point. All right, so this one is 5 and x is raised to the 7. And then that's divided by e to the x. And then it says that it's from 0 to infinity, so just change the window, go from 0 to, I can't make my calculator go to infinity, but I'll go to 100 and see if I can see what's going on. Okay, so right here, the graph is pretty much leveled off at the x-axis, and then it went up like this. And I can't see where it is, but if I trace, and it's going to go off the screen for a second, but I just watched these y values. So it's in the 60s, the hundreds, 500s, 700s, 1,000. Oh, right there. So it went up to 37, so 3,500, 3,700, 3,600. So right here is where it's reaching its peak. So at about 3,700. So if I change the window and tell it, for the y values, go up to, let's say 3,800. And then hopefully I can see the whole graph. Okay, so that's the maximum up there. So the absolute maximum. So let's see, I'm going to zoom in on this little peak right here because I really need, it's only asking for the maximum. So it's really just asking for that peak right here. Where is that absolute maximum? So I'm going to make the window a little bit smaller. And then down here, this is 20, so this is 10, so this is approximately 5. So if I trace and I put 5, 6, 6.5, it's getting close. So I can also ask the calculator, where is the maximum? So move the cursor to the left and hit enter. Move the cursor to the right and hit enter. And then close to the maximum and hit enter. And it says that that point is at 7, 3754.87. The absolute maximum is round to 2 decimal places. So the absolute maximum is 3,754.87, goes in that box. And when x equals the 7, so that is number 31. And then, I don't know why I didn't go in order, but this is number 14. So they give you this information, and then they ask you which graph is it, which is the correct graph. So for one thing, this is saying that when you follow the left and the right, there's a horizontal asymptote of 3. So where is there a horizontal asymptote? This one doesn't even have a horizontal asymptote, so this one's out. This is a 4, and that's a 3, and this is a horizontal asymptote. So this one is at least possible. This one has no horizontal asymptotes. This one also has a horizontal asymptote, so both B and C are still in the running for the answer. And then it says, so these two W-looking shapes do look very similar, but this one is rounded right here, and this one is more of a sharp shape. So if you zoom in, here, let me zoom in. If you zoom in on that part, then you'll see that this is a sharp point and the derivative does not exist. And if you look at this part, it's saying at the derivative does not exist at 0. And then that means it's a sharp point like this. So this one at 0 is rounded, which means the derivative equals 0. This is a sharp point, so the derivative does not exist. That means that C is the winner. All right, so that's it. If you have any further questions on the homework, please email.